Okay, Algebra 1 fans, our topic for today, this is Notes 3-2, Functions and Relations. Our objectives for the day after this lesson, students should be able to understand what it means to be a function and determine if a relation is a function, and evaluate functions using domain and range. Before we begin, let me give you your joke of the day. How do you tell if a vampire is sick? By how much he is coughing. Yeah. All right, so we talked a little bit last notes about what relations are, and a relation is a set of ordered pairs. A set of ordered pairs. Ordered pairs are x comma y. So in number one, there are different ways we can look at relations. One way, we can graph the following relation on the coordinate plane. So the relation, you'll see here's the set, the brackets. That means that's a set, a group of data. These are all xy's. These are the ordered pairs, the points. So one way that we can look at a relation is to graph them. So negative 2, 5, we go from 0, 0, we go left 2, up 5. Negative 1, negative 3 is left 1, down 3. And that's in the third quadrant. That's the second quadrant. 0, negative 2 is going to be on the y-axis. 3, 0, x is 3, y is 0, is on the x-axis. And 5 comma negative 3 is right 5, positive 5. And for y, negative 3 is down. And those are the points. Okay, so we can graph a relation. We can also, so this is a graph, we can also write the relation as a table of ordered pairs. So we have the x's, we always put the x's on the left because those are first. So negative 2. And the y value is 5. So the y value that matches to the x value is negative 2. And then when x is negative 1, the y is negative 3. When x is 0, the y is negative 2. When x is 3, the y is 0. And then 5 and negative 3. And it is important that I don't mix these up. The y values go with a specific x value, so I have to make sure I match those correctly. Another way to look at a mapping, it's not as common, to look at a relation, is what we call a mapping. So a mapping is similar to a table. There's two ovals, and we write all the x's in the first one. So negative 2, negative 1, 0, 3, 5. For the y values in the right oval, so here's 5. Now you'll notice there's two negative 3's. I don't need to write it both times. I'm just going to write it one time. And what we do is we draw an arrow from the x to the correct y value. So negative 2 maps or matches to 5. Negative 1 goes to negative 3. 0 goes to negative 2. 3 goes to 0. And then positive 5 also goes to negative 3. Now, we don't see this so often, but a mapping, again, is very similar to a table. Well, this leads us to two words that we also talked about last lesson. The domain is another word for x values. It is the set of x values, or x coordinates. We would say capital D for domain equals, now it is a set, so we do a bracket. We don't use parentheses, we use a bracket. What are the x values? Well, negative 2, negative 1, 0, 3, 5. Negative 2, negative 1, 0, 3, 5. That is the domain. So when you hear the word domain, you're thinking x. When you hear the word range, we're thinking y. The range is the set of y values. We'll use capital R for the range. And the range, here are the y values that we put into the table. Now, I'm going to write these in order from smallest to largest. The smallest value is negative 3. Now there's two of them, but again, I only write it one time. So we have -3 and then -2. Then we have 0, and then we have +5. And what this leads us to is really the key for today, is what we call a function. Now the function has a very long definition, but kind of the shorthand definition, a function means that for every x value, there is exactly one y value. For every x value, there is exactly, another word that I could use is only one y value. Basically what this says is that x does not repeat. The x value cannot repeat. Now, one of the things that I like to visualize what this is actually saying when we write a definition. What does this actually look like? Think of a machine. Here's my machine, my function machine. I'm going to call that f of x. That's how we write a function symbolically. The idea is that we take an x value, we substitute it, we put it into the machine. So here's our machine that does something, and what comes out is a y value. So the main idea for a function, you put in an x value and you get out a y value. So if I put in, and I'm going to use an example here, if I put 2, I'm just making this up, into the function, let's say that I get 3. Okay, so however that works. The idea of a function is that x can never repeat. Every time I substitute a 2, when a 2 goes in, when the domain goes in, I have to get the same range every time. So it doesn't make sense if I put a 2 in the next time and I get a different answer. That is not a function. Okay? So you put in the x, you get out a y, but you only get one y for that. Now if I put in a different x, if I put in 0, then I probably get a different y value, most likely. That's okay. All right, but the key thing for a function is x cannot repeat. X does not repeat. Okay, so in number 2 here, we're going to do some examples. Are the following functions? State yes or no. If it's a function, state, that means write, the domain and range. Okay, so for a function, the x's cannot repeat. So if I look, here's xy, xy, and I like to label this. So we're only going to look at the x's, 5, 1, -3, 0. Those are all different. X does not repeat, so that means yes, it's a function. The domain would be the x values. So let's see, the smallest is -3, and then 0, and then 1, and then 5. The range, I'll put that in red. Here's the y values. The smallest range value was -4, and then 0, 1, 6. Okay, so that is a function because for each x value there is exactly one y value. All right, let's look at B. Look at this set of ordered pairs. xy, 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 xy. Well, we have a problem. Notice that when x is 3, the y is 3 here, but when x is 3, the y is something different. How can I put the same number into the function but get out different values? Okay, so no, that is not a function. Now we could still say there is a domain and range, but they only ask us to state that if it is a function. Okay, so it's not that if I wanted to, you don't have to write this. The domain would be -2, 0, and then the x's repeat, the 3's repeat. So I only write it one time. So I could still write it, but in this case, I don't really have to. You'll notice here the y's repeat. That would actually be okay. So -1 and 3 and 5, okay, for the range. Now, what if I'm looking at a graph? How can I determine if this is a function? Well, what does it mean to be a function? X does not repeat. If we're thinking of this visually, let's say that I'm going to draw a vertical line. Okay, I'm going to draw a line up and down. Notice that this line goes through, here's my graph, this curve. Notice that the vertical line intersects this graph, this curve, 1, 2, 3 times. Okay, now why is that significant? Well, if I write the ordered pairs, and I know this doesn't work out perfectly, but this is approximately 3, -3. Okay, x, y. This is around 3, -1. Now I know it's a little bit lower, like maybe -1.5. This is 3, almost 4. So if I write the ordered pairs, look at what we have. We have a problem here. The x's are the same. So normally we don't need to write the ordered pairs. What we use is called the vertical line test. If the line up and down goes through the graph more than one time, that means that x repeats. And if x does repeat, that is not a function. So we use the vertical line test to show, okay, I'll draw an arrow over here. If the line goes through the graph in more than one place, that means that x is repeating itself. We have the same x value, but we have different y values. That can't happen for a function, so this is no. Now in this graph, this curve, okay, if I draw a vertical line, notice it goes through one time. How about over here? One time. One time. And now the arrows mean that it's going to keep going. It'll keep going left and right. It will keep going up, okay? But even way out here, if I draw the vertical line, it only goes through once. So what this means, x does not repeat itself. Yes, that's a function. Now the domain, and this is something that's a little bit tricky to think about, but the idea of the domain is the set of all the x values. Well, this arrow means I'll keep going to the left. If I take x is -5, somewhere up here is going to be a point on the line. If I take 1.5 here, somewhere down here, there's going to be a point on the line. There will be a y value. So the thing is, from the left, this is going to keep going. And if to the right, this is going to keep going. So in this situation, all the real numbers will have y values. So the domain, the way we would write that is we would say all real numbers. Okay, there's my number symbol. Every x value that you can think of is going to have a corresponding y value, a matching y value. Now the range is up and down, that's the y's. The arrows mean that we're going to keep going up. But you'll notice that if I travel here, notice that I hit this point down here, but then we turn and we come back. So what's happening, the graph comes down to this place, but it never goes below because it turns and then it's going up and up. Now, how far up is it going to go? Well, we say it goes to positive infinity, okay, because it's never going to stop. How low does it get? Well, the y value here is at -5. So the way we'd write this is we would say it's all real numbers greater than or equal to -5. Now if you wanted to write greater than or equal to like that, that's a nice way to do it. All the reals greater than or equal to -5. So that's the low point. Everything above is going to be part of the range. All right, the last one here, E, we have a horizontal line. Now if I draw vertical lines, one place, one place, one place, one place. No matter how I draw my vertical line, it only goes through the graph one time. So is that a function? Yes, because x does not repeat. The domain is your x values. So how far left and how far right do we go? Well, the arrows tell us that we go left all the way to negative infinity, and we go right all the way to positive infinity. So we say the domain is all real numbers. Now the range is the y values. If I take these points here, this is 2, 3, and here's negative 2, 3, and here's 0, 3. Notice the y values are going to be the same every time. Because this is horizontal, we're always going to stay at the same y value. So we say the range is just the number 3. It's the set of that one number. And that's okay. The y values are allowed to repeat. It's the x's that cannot. And that is the end of part 1.